Hello, beautiful people. Future me. Welcome to another programming practice of mine. So we'll start with 5 minutes of typing. So let's go. Slow down. Focus on the errors. Okay, it's almost also on the time. So what is my ratio? 5%. That is better than some time ago or the last time. So let's call it a progress. we are out of the time. That means we will progress to another topic, and the topic today is execute program, and in there, and it's not TypeScript, it will be SQL this time. I believe. Let me check. And yeah, it will be SQL, so let's go. And start the clock. Left and right joins. In an earlier lesson, we saw example users can register with discount codes. The discount codes are optional. Some users register with a code, so they have foreign key to the discount. Other users without code, so the foreign key is null. Suppose that we want to produce a report listing our users and what discount or codes they used. The report should include all users, whether they used a discount code or not. We could write a loop in JavaScript, loop over each user, selecting any discounts for that user. That would cause an n+1 query problem. We'd query all of the users followed by n individual queries to get each user's discount, if any. Imagine that n is 10 millions to see why this is a problem. Too many queries. As usual, SQL has an answer. In this case, it's join. However, the type of join that we've seen so far doesn't help us. If we select user join discounts on user's ID equal discounts user ID, we'll get only results for users who have corresponding discounts. The user's ID equals user will never be true for users who has no corresponding discount. No, yeah, that's right. That doesn't solve our problem because we want to include all users even if they have no discount. Here's an example of that solution, even though it doesn't solve our problem. So what do we have? We have a table of users with ID, name, and discount ID, which is a foreign key. The discounts and can be known. Then we create a table of discounts with two fields, and that is the primary key and discount code. Then we have a mirror with, and we have a discount, which is his discount, and then the one, yeah, sure. So, and the Betty, and Betty has no discount code in here. Now we will select name and the discount code from users and discount, and we will join them on the ID field. So now we will get end results, and it will be the name for Amer, and then discount code, and that will be free month, like so. And that is all of the results since Betty does not have a thing in here. So let's go. Betty existed, but she wasn't in our queries results. To fix that, we can tell the database to include users in the report even when there's no matching discount. This is called left join. Users left join discounts. The left means include rows from the left table, which is users here, even if there's no corresponding row from the right table, discounts in this case. With a left join, both Amir and Betty will show up in the results. Amir will have his discount code, but Betty discount code will be null, which will be represented as JavaScript null. So here we have the same thing, and then we have a select where here is the left join instead of a join only. So we will get the result and it will contain our Amer. That will be the same. Fremont. And then we will have a Betty in here as well, and her discount code will be null. So I can close this and the result array and try my luck. And I'm lucky today. Left join adds one small tweak to our mental model of joins, inner joins, the simple kind that we've seen without left. Still work in the same way, but there's how the database executes a left join. The new part is the if now discount match this user section. So for each user, for each discount, if this user discount matches the ID, return a row with all users columns and all of the discounts column. Okay, now here's the new part. If no discount match this user, return a row with all of the user columns and nulls in all of the missing discounts columns. All of the columns, okay. As usual, this is only a mental model, but it's a correct one. In reality, the database will use a more efficient method that gives exactly the same result. You might wonder whether the left join implies that there's also a right join. There is. In a right join, rows from the right table are always included, even if there's no corresponding row from the left table. Left and right joins are much less common than the basic inner joins that we've seen before, where every row must exactly match on. But when you need a left or right join, you'll be glad that it's available. They are useful when you want a list of records like users, along with other corresponding records like discounts, and that may or may not exist. Exist. Exists. Exist. 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 As is often the case, SQLite is a bit weird here. Great. It supports left joins, but not right joins. Fortunately, we can convert right joins into left joins by flipping the order of the tables. Easy. Like with basic inner joins, left and right joins will produce any combination of rows that match. For example, suppose that we select from users left join comments on users ID equal comments.user_ID. Every comment in the database will show up in the results. If Amir has written 100 comments, he'll show up 100 times, once with each of his comments. Okay, and that is users left join comments. Okay. But because it's a left join, every user is guaranteed to show up at least once. Betty will show up even if she's never written a comment. Here's a code problem for you to solve. Use a join to get a list of usernames and comment texts for every comment in the system. Make a join that get list of usernames and comment text for every comment in the system. Make it a left join that it also includes users who have never written a comment. They'll have a null comment text. Select only the name and comment text columns. So we can do that. So we will be selecting two things. They want comment text, and that will be what it is. So I want this thing. This comes from comments table and comment text. Okay, so we can do comment text. That looks okay to me. And then we will have the name, user's name, and comma, and here users dot name, and here we will have from written in here from users left join comment, and we will be joining on comments dot user ID, maybe it is comments user ID, it is user ID equal to users dot ID, I believe. Yep, it is. So this should be it, and it is not. So no such column. Comments, comment. Okay, so I have a typo in there. It's here. What about now? Now it's good. So what I was trying in here is if I can do, say, just comments, comment text without putting on it the alias when I join two tables, and I don't have to. So I don't have to write users.name as name. I can just say users.name and it will put the name. So it's fine. It's okay. Don't worry. You'll sometimes see left and right joins called left outer joins and right outer joins. Fortunately, outer doesn't challenge the meaning, it's just more precise name for the same idea. So left outer join is the same as the left join, and right outer join would be the same as right join. Okay, well, I can write the outer if I want to, I guess. In this course, we only address a simple joins and left joins. However, there's a surprising array of additional join types. For 99% of your practical work, inner joins will be sufficient. Left joins will probably get you through the final 1%. Oh, really? So 99 is the normal join, the inner join, the normal, it's inner join, okay. It's the first one I saw. And the left joins will probably get you through the final 1%. Okay, so I'm covered. Because 99 plus 1 is 100. We don't recommend focusing on other join types until you spend a lot of time using SQL databases on projects. However, if you'd like a taste of how deep the join rabbit hole goes, we think that this article is thorough and understandable without belaboring the point. What this means. Okay. And we are done. And I have a review to go through. So we are creating table with email, text null, unique, and then we are inserting two same values into that column, so that is a problem, and we will get an error. Finish the function people and cats so that it creates a list of each pair of cat and person. For every cat, call results push person.name and cat. Okay, to build up the list of results. Okay, so we have the results array on top. Then we are selecting all of the people. Then we are iterating over the persons in a people array. And then we are doing another query. And so we are tying up the cats owned by person, and we are having cats owned by person. Okay, so for person, we are getting its cats and we have it in array. Now we want to push in here the thing. So the thing being the pair of cat and the person who owns it. So it will be kind of easy. So we will be returning an object, and the field cat will have a value of cat.name, and the second field will be person, and the value will be person coming from here dot name, like so. Like the semicolons in here, and we are returning it over there. So if I press enter, the green should light up, and it has. Here's a code problem for you to complete. Add a entry to the results array for each person and cat, where cat owner ID equals person ID. You can use the same thing I did. You won't need to add any more database queries. So we have this two queries over there, and then we are iterating over them. And then if we will have a match on the IDs, so that is a person dot ID equals cats dot owner ID, then we will add it to the result array. So we will do just that, and that is our results dot push, and we will be pushing the object with the cat and person fields. So the cat will be cat.name and person will be person.name, like so. We can close this. Semicolon is always nice, and we'll close the if statement. We have the return below it, so if I press enter, we should be happy. And we are not, because I did a poo-poo, and that is here we supposed to be pushing in an object, and I did not. I was pushing like two things in it, and so I'm missing the curly braces as I did it in here. So that was my mistake. Oh, we can fix it next time, I'm sure. Don't worry. The next example, we are creating a table of users called users. We have a one column, email, text, null, unique, and we are inserting two nulls in there. And this example just shows that we can have a multiple nulls even if we have a unique constraint in there. It's kind of unique does not check for nulls, or nulls are immune to unique. Depends how you want to see it. So we will have the first one, it will say email and the value is null, and the second one will be exactly the same, email and the value is null, and pressing enter will show us the green color which we like. Now we can fix our errors. So on the match of IDs, which is person.id strictly equal to cat.ownerID, we will insert an object, which I did not do last time, into a results array. So let's do that. So we have a results dot push, and inside of the push we will be putting in the object, and the two fields will be cat and person. Cat, the value will be cat.name, and the person will have a value of person.name. So I'll go here, enter that. Okay, now it should be okay, and it is. It's great. Okay, so and we are done with SQL. I cannot do more SQL. Okay, so I have to wait. So let's do some typing practice in the rest of the time. This will be super slow given that I kept it running for the entirety of the other part. Come on. I need to trim my nails. Come on. All right. I'm still making some mistakes, but say 9%. Oh well, I was hoping for better score, but it is what it is. Let's just continue in the practice, shall we? Okay. kind of helps, I think, if I intentionally release the tension in my wrist or in my forearms or whatever. Well, this will be not completed because our timing device says that we are done, and done is better than perfect every single time. And I will see you next time. Bye.